Okay, so I stripped the rubber off of the casting, and to see what changes that I'm going to make to the device, I have to also add the silicon. I know I have to add that. I know I have to add the permanent magnets between the segment, bulge between the segment, and fix within the silicon and silicon carbide and resin to lock it into that segment. So what I did was, once I stripped the rubber off, I applied the magnets. Now I'm going to show you the separate parts on how it is. So I'm going to take this off, because this may come off because it's not mounted on the permanent state. See that hole there? And you know what that is? That is a permanent magnet, or a ceramic permanent magnet with a bottom and an open clearance. And the bottom is iron, and the coil is alongside that permanent magnet. Do you see it? Okay, so that's the backside of the foot mount, and the aluminum is fixed within the magnet field right there. So I'm going to take this out. And this is 1.8 of an inch. This is about 3 millimeters thick aluminum. Now, this is the other part of the magnet. This is another magnet with a winding coil around it. And that material compound that is localized on there is silicon. That's silicon carbide that is localized on there, mixed with resin onto the wire to protect the wire. Now, the wires are flattened to the surfaces. However, the coils are enclosed in a thermoplastic. See that resin? Thick resin over it, so it protects it from kind of damages of the wire. Even though this is going to be a synchronous lift. Now, notice that the coils are localized by the magnets, and that it will cause the magnets effects within the central, so it causes either to move upward or downward, to where it causes the coils to escape from the inertial mass. Now, I have at the bottom an iron, and this iron is used to magnetize for magnetism for the flux of the coils. Now, along the side, because I'm going to make it more smoother than this, because I got to flatten out the edges, and I got to pound it with a rubber hammer at the silicon carbide, but there's more materials that must be added, and that is going to be the silicon carbide wire, and the silicon carbide compound, and the boron wire, just in case I don't want to add more of a flux, and just add the boron wire here in a zigzag fold, and then submerge all of that in an epoxy resin crystalline hardener. And that, when I mix it, I'm going to mix it also with the carbine. So it's going to look wild for a solid state. But while I do that, before I put the boron on, I promise to put the permanent magnets going alongside within the central lining of the coils. So within the central of each coil of the linear coil, which, as you can see, that it has the pull and the push, where 3 loops are, one loop is overlapping the 2 loops. So one loop overlaps the 2 loops, which makes it, which reacts as a linear motor. And that will cause it to escape into the air. Now, the following magnets I'm going to add to it, and then the silicon carbide wire, and then the silicon carbide mixed with the resin, and with the aluminum and the central. And then I can put the gate on, which is the aluminum gate. And I wanted to cut it short, and the reason why I have it separate, because remember in the Iron Man picture, I believe that this transformer type boot did actuate as far as like a linear motor and move backwards to separate to allow him to get into the unit. So I'm going to make a little tracks here. I'm going to tighten the edges with a winding iron to the edges, and a helix type alongside the edges. It'll be real buckled, real tight along the side. And I'm going to ground all the phase wires by using another piece of metal of iron at the bottom of this, so I can ground all of these phase wires that are loose out towards the inside hole areas, where we're going to make a little bunch of micro holes to apply these phase wires into it. Now, even though this is going to be a synchronous motor, I'm going to be charging it through another coil that I'm going to be facing on top of it to allow it to synchronize this transformer type. And while, remember that the repulsive force is determined by the winding turns. These turns are greater than the inertial mass of the magnet, and greater than the mass of the magnet, and greater than the mass of the aluminum. So long as they are 10 times greater, the turns are 10 times greater than the repulsive masses of the common, and in addition to the magnets, because the common, it will lift with the common, but to get more energy for lift, I use magnets. So the enclosure frame that I'm going to be doing. The enclosure frame, obviously, is like the gate of Mark 40, the first was Mark 2, I guess, and it was in the Iron Man 1 of the first video, where you see the framework like that. So that's going to be added to it. However, I cut the ends, so I can have the drawer guider move up and down, because you know this is aluminum, and it will lift up and down, and move up and down. And I guess that's how I'm going to have it, and try to get it to fly in the air, but I want it to be articulate. So, before the central, when I put the 2 here, the one metal, actually one copper and one iron stacked with the aluminum, and then I'm going to cut it to like a latch and allow it to collapse on both sides, so that I could fold it. And the reason why the top is cut short, like a short 20, and not 40 below, or 40 height shoes, boots. I am, but that's in the later. I just have to do one part and then do the other part. It's going to be telescopic over another part. So just give me a chance. My name is Jermaine Morton, and I'll be happy to wear these boots. I'll be happy to wear these boots. I wonder what you would think if once I get into it. Don't worry about it. The coil's not touching against the surfaces. I'm just going to brush to see how it looks with my feet in it. My feet in the segment. So, So just wanted to look to see how it would look or appear as with my feet into the segment. And I plan to also use, oh, one thing I almost forgot. I'm sorry. Copper coil tubings will be also added. Coil tubings as far as aluminum tubings actually, not copper, aluminum. And that's going to be used to spray the antifreeze. So I'm going to be adding them in loops, in oval loops, so they may fit within the section of the open clearance of the coils that are stacked in linear motion. So long as I stack them in loops and connect them like a fire cage, like a fire cylindrical, where the flames come out by multiple holes, where it has bladders that bleed it out into a tornado. So I'm going to bend the tornado into an oval so that it fits central within the coil winding. And that stuff, I forgot about to tell you about that, about the antifreeze. So they may maintain also the coolnesses along with the thermocouple using silicon carbide within the electromagnetic field. So, my name is Jermaine Morton, and goodbye.